Hello everyone, I hope you all are doing well. So today we will be starting with this chapter, Binomial Theorem. Now this chapter in itself, I wouldn't consider this to be a very important chapter because JEE does not generally ask direct questions from this chapter, although there are a few times JEE has asked. However, mostly the concepts that you will study in this chapter will be used in further chapters as well. For example, if you are going to study permutations and combinations, you will see that a lot of things have been used from binomial theorem only. When you will learn probability and statistics, that time also concepts of binomial theorem would be used. So that makes this chapter a little bit uh, important for you to study. However, there are of course not many direct questions from this chapter. There are a few which we will look at the end of this chapter. So first, let's look at what are the subtopics we will be covering. First, we will look at a brief introduction as to what binomial theorem is. Basically, we talk about x plus y to the power n and how can we expand it. This entire chapter is only about the expansion of this term. So then we will look at a standard way of expanding it, terms from the end, remainder, fractional theorem, multinomial theorem, and how we can find out the greatest term and for any other index, whatever the value of n is, and a few more things. So without further ado, let's start. So binomial theorem, as I mentioned, it is a way to expand expressions which are in the form a plus b to the power n. So how, in general terms, if let's say I was to expand a plus b to the power n, how can I expand this? This expands in this way: nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b plus nc2 a to the power n minus 2 b square plus, and this goes up till the value of n, where we have ncn a to the power 0, so this becomes nil, and b to the power n. So this is how generally this type of things are expanded. Now what is nc0? This is a new term that you must be looking at. We will talk about this in the next slide, but this is a general standard expansion of a plus b to the power n, and that is how we write it. Now here you must be seeing that if I was to write down, let's say, the general term of this entire equation, how can I write it down? I would write it down as NCR, or generally it is represented by R, so we write it down as R, a to the power n minus R, b to the power R. So this is how my general term is written, as you can see here in this equation. So this is basically nothing but my general term of this entire equation. General term of this entire equation. Now you must be thinking that I have written here NCR, or I can write it down as NCK as well. And here in this expression they have shown you in this way. Both means the same thing. It is basically we are trying to find out the coefficient of any variable that we are finding out. So it can either be represented as this, or this is also equal to NCK. Let's look at what basically is the value of NCK. So this is NK, or it can be written as NCK. This is known as the binomial coefficient. So it is calculated in this way. It is n factorial upon k factorial into n minus k factorial. So let's say if I was to find let's say value NC0, so what would this become? NC0 would become 1. If I was to find, let's say, NC1, what would this become? This would simply become an or how am I finding this? I will just write down the formula. This becomes n factorial by 0 factorial into n factorial. N minus k factorial becomes n factorial, since k here is 0. For this one, I can write it down as n factorial upon 1 factorial into n minus 1 factorial. Now I hope you all know that n factorial can be written down as n into n minus 1 factorial. Basically n factor, I hope you all know what factorial is, right? Factorial is basically, once, if let's say I have 8 factorial, so this means that I have 8 into 7 into 6 into 5 into 4 into 3 into 2 up till 1, right? So that means I can write this down as 8 into 7 factorial. So that is exactly what I did here, and that is how I came up with the value of NC1, which is n. So this is how we find out these values. Now let's say if I was to find NCN, that would come out to be 1 again. Now there is a shortcut trick to calculate the binomial coefficient. Now every time you do not have to use this entire formula to find out your binomial coefficient. Of course, it is going to be very lengthy process and time taking for you. So what is the shortcut way for you to calculate any binomial coefficient? Let's say I have 7c2. I have to find out 7c2. So instead of using this entire formula of 7 factorial upon 2 factorial into 7 minus 2 factorial, I can simply, what I can do is, I can directly, since I can see that there is a number 7, there is a number 2. So what I do is, I open 7 twice, or I say this is 7 into 6 upon 2. Simply I can write this down and I can find out the answer. So this would also be equal to 7 factorial upon 2 factorial into 5 factorial. Because if you try to look at this entire equation, how can I write this 7 factorial? It can be written as 7 into 6 into 5 factorial upon 2 times 2 factorial becomes 2 into 5 factorial, and from here 5 factorial gets cancelled out and we get 7 into 6 by 2. So directly I could have written this down. Or let's say if I have 10c3, so how can I write this down? I can write this down as 10 into 9 into 8 upon 3 into 2, 3 factorial. So this is how, this is a shortcut trick for you to find out the binomial coefficient. Again, there isn't much shortcut involved here. Of course, you can directly use this formula as well of factorial. We simply are just cancelling out the n minus k factorial from the top. So, but this helps you to remember and find out your binomial coefficients easily during exams. Let's say if I have 10c3, that means my k value is 3, so I will open 10 3 times. So at top there will be 3 different numbers, 10 into 9 into 8. It will be decreasing by 1, and below I will have k factorial. So that is how binomial coefficient is calculated. Now coming back to this equation again that we studied. So from now we know what our NC0, NC1, NC2 is in each and every term, right? And each and every term we have certain value of a to the power and certain value of b to the power. In the first term we have b to the power 0, and in the end we have a to the power 0. So you have to remember this. This is how a general binomial theorem or binomial expansion occurs. Now if I were to tell you about the proof of how this thing entire works. So this diagram here, this basically is our Pascal's triangle, is what we call as our Pascal's triangle. What do we do here is, this one here, this can be written as 0c0. 0c0 would be what? It would be 1. What would, here we can write this down as 1c1, and this one can be written down as 1c1 again. Here we can write this down as 2c1, sorry, this would not be 1, this would be 0. 1c0 and 1c1. Here what this would be written down as 2c0, 2c1, and this becomes 2c2. What is the value of 2c2? 2c2 would be 1, 2c1 would be 2, and 2c0 would be again 1. Anything, be it any value of n, if the k value is 0 or if k is equal to n, then that value would come out to be 1. So here also we can write this down as 3c0, this would become my 3c1, this would become my 3c2, and this would become my 3c3. If let's say you are getting confused, then let us find the value of 3c2. What I can write this down as 3 into 2 upon 2 factorial, so 2, this cancels out, so we are left with 3. This one can be written down as 4c0, 4c1, this would become 4c2, 4c3, and this would become 4c4. So basically what we are saying is, when k is equal to n, that time our nk, or basically nck, this can be written as nck. Now at all times you are going to be seeing either of these two variables being used during your questions. In question they can give you the question in this format or using this format, so you will have to understand that both these things represent our binomial coefficient. If n is equal to k, so we would have ncn, and this would be equal to 1. And whenever we have k equal to 0, that time what would we have? nc0, so this would also be equal to 1. So you must remember this thing. Now if I look at this, if I were to, let's say, x plus y to the power n, now this n is increasing it at each and every step of my Pascal's triangle. So first I'm taking it to be 0, Of course, anything to the power 0 is 1, so we get 1 here. If I put the value of n to be 1, this becomes x plus y. So basically, if I was to expand this in the standard form of binomial coefficient, what would I write this down as? 1c0 x, again this would become x to the power 1 y to the power 0 plus 1c1 x to the power 0 y to the power 1. And if I simplify this, what is 1c0? It is nothing but 1 x to the power 1 y to the power 0 again becomes 1, so this becomes x plus y. So that is how we came to this conclusion. Now if I was to write down this equation, how can I write this down? This would become 2c0 x to the power 2 y to the power 0 plus 2c1 x to the power 1 y to the power 1 plus 2c2 x to the power 0 y to the power 2. And if you look at this, equation exactly turns into this one. This becomes 2c0 is 1, y to the power 0 is 1, so we are just left with x square. Here 2c1 is 2, x to the power 1, y to the power 1, so 2xy plus 2c2 becomes 1, x to the power 0 becomes 1, so we are left with just y square. And similarly, you can do this for the further equations as well. So basically, this Pascal triangle proves that how we are basically expanding our binomial or any type of equation in using the binomial theorem. Now there are a few properties of this thing that you must remember. Whenever we expand this, there are going to be n plus 1 terms. So of course you can see this from the Pascal triangle as well. When my n was equal to 0, how many terms did I have? 1. So it is n plus 1. So this is basically 0 plus 1 number of terms. When my n is 1, that time how many terms do I have? 1, 2. I have 2 terms. That means again n plus 1. When my n is 2, again I have 3 terms. So basically what do we understand is that if there is a plus b to the power n, then the number of terms is going to be n plus 1 terms. And each term is in this format. So basically this is our general term. General term. And now you must look at one more important thing. The sum of exponents in each term is always equal to n. You can see from the example in this Pascal triangle. Since my n, let's say in this equation, let me take this equation for example. Here my n was equal to 5. In each term, the sum of coefficients of x and y will be equal to 5. See, here you can see that we have x to the power 5, y to the power 0. So 0 plus 5 is 5. Here you can see x is to the power 4 and y is to the power 1. So 4 plus 1 gives us 5. Similarly here for 3 and 2 we get a 5 again. Now if we look at the general equation that we studied at the first, what we had written this down as nck a to the power n minus k b to the power k. Now if I was to add the coefficients of a and b, what would I get? N minus k plus k. From here k and k gets cancelled and we are left with n. So again, our general terms also signifies this thing that we are talking about. So the sum of exponents in each term is always equal to n. Now binomial coefficients are symmetric. That means nk would be equal to nc n minus k. That means nck would be equal to nc n minus k. Of course, I hope you all must have seen nc0 is equal to ncn, which is equal to 1. Similarly, nc1 would be equal to ncn minus 1. This would be equal to n. I hope you all know the value of nc1. It is n. We looked at this in the previous slide. Now, to prove this, let me find out the value of ncn minus 1 for you. This can be written as n factorial upon k factorial. K is our n minus 1 factorial into n minus k factorial. So here my n is n and k is n minus 1. N minus 1 factorial. So if I try to open this up, what am I going to get? This would become n into n minus 1 factorial upon n minus, let me write this down. Let me write this down here. So this becomes n into n minus 1 factorial upon n minus 1 factorial. And this can be written down as, what does my n minus 1 becomes? So this would become, sorry for that. So this would become 1 factorial, and from here n minus 1 factorial gets cancelled out and we are left with n as our answer. So again, so you must remember this, that the binomial coefficients are symmetric. That means coefficient of terms that are equidistant from the beginning and from the end. The coefficient, I'm talking about the coefficient, not the term. the binomial coefficient from the start and from the end is going to be the same. So you must remember this. I'll write it down for you as well. Binomial coefficients equidistant from the start and end are equal. So you must remember this thing. Now again, the same things have been mentioned here using the Pascal triangle. We came up to this general equation where we mentioned t k plus 1 or any term t in this entire binomial expansion, this expansion that we did, any term t can be written down as t k plus 1 n c k a to the power n minus k b to the power k. Now this is k plus 1, so you must remember this thing. This is not the kth term, this is k plus 1th term. So if you look at here, see, this is my first term, this is my second term. So let's say if I was to find out my second term, so what would I say? T1 plus 1, that means I'm taking my k to be 1, and from that equation what would I get? nc1 a to the power n minus 1 b to the power 1, because my k is 1. So I hope you are understanding what we are trying to say. This is basically my second term. So you must remember this thing and not confuse yourself with it, that this is k plus 1th term and not the kth term. So now we'll look into the standard way of expanding a few different types of binomial theorems.